In this video, we'll take a look at notes on section 9.3, vector addition by components. So if we're adding our vectors at right angles, it's nice it makes a right triangle. And then we're going to use this property as we add vectors that are in different places around in standard position. So if we want to add vectors a and b with a equal to 14.5 and b equals 9.1, remember that we start with our vector a, and this has a length, a magnitude of 14.5. And then we put the terminal side or terminal side of A with the initial side of B, and B is 9.1. So what we've made is a right triangle. And what we want to find is the resultant vector. That's the initial side starting at A, terminal side where B ended. And we find this using the Pythagorean theorem. So r squared is equal to 14.5 squared plus 9.1 squared. Square root both sides, and r is equal to, let's put that in the calculator, square root 14.5 squared plus 9.1 squared. And we end up with about 17.12. So the magnitude of r is 17.12, and r is the resultant vector. We want to find the angle, so we need both direction and magnitude. To find that angle, we're in the right triangle, we're given the opposite and adjacent side. So we're going to use the inverse tangent of opposite over adjacent, 9.1 over 14.5, and that's going to tell us our angle. So it's right triangle trigonometry to find those. And we end up with about 32.1 degrees. Okay, so this is if you're given the lengths of each vector, the magnitudes of each vector. You can find the magnitude of the resultant, and you can also find the angle. So what if you only know the resultant vector, the components, and you have to find magnitude and direction? So if r sub x and r sub y are the components of the resultant vector, and what that means is it's the x and y coordinates of the terminal, or the initial side or initial point starts at the origin. Then the length of your vector, the magnitude, is the square root of r squared of your x component plus r squared of your y component. And then the reference angle is the inverse tangent of basically your opposite over adjacent of the reference angle. So if we want to find r and theta given the components, r sub x equals 8.416 and r sub y equals negative 5.018, those are basically giving us the x and y coordinate. So the x is 8.416, y is negative 5.081, and what we're given are the x and y components, there's the x, there's the y, of the vector that we're looking for, which is this one. Okay, so to find r, it's equal to the square root of the two sides. If you were to drop this down, it would make a right triangle. And this side over here has a length of 5.081. So when we're looking at lengths, we're not looking at positives or negatives. So we get Pythagorean theorem, 8.416 squared plus negative 5.081 squared. And that's going to be the length of our vector. So now we've got it on the xy axis instead of as just a triangle. So we get square root of 8.416 squared plus, I'm going to square this so I'm not too worried about the negative sign, 5.081 squared, and I get a length of about 9.83. We want rounded to the nearest thousandth. That's 3 places, so that's 9.831. So that's the magnitude of our vector. Now we want to find the angle. So the formula tells us the reference angle. So the reference angle is going to be the inverse tangent of the absolute value of the y component, which is a positive 5.081, divided by the absolute value of the x component, 8.416. And what that's going to give us is not the angle that we're looking for. It's going to give us our reference angle. Then the angle that we want is the angle from standard position. That's the angle that we're looking for in this problem. But the formula will give us the reference angle. So we want inverse tangent of 5.081 divided by 8.416. And that equals about 31, what do we want? Round to the nearest tenth. So the reference angle is 31.1 degrees. But the angle that we want is the angle from standard. So we're going to have to take 360 degrees minus 31.1 degrees. And that will be the direction of our angle. So 360 minus 31.1. So you're going to add or subtract depending on where your reference angle lands. So we get 328.9 degrees. So there's our magnitude and our direction. All right, we're going to take this one step further now. What if you're given vectors that are not at right angles, and not only that, you're given the magnitude and the direction, but you don't know the x and y components? So if the vectors being added are not at right angles, you have to place each vector with its tail at the origin. Then resolve each vector into its x and y components. Then add the x and add the y components to find the x and y components of the resultant. Then by using Pythagorean theorem, we can find the magnitude, and by using tangent, we can find the angle. So our example, we're going to determine the resultant of the vectors with the given magnitudes and directions. Positive angles are measured counterclockwise from the positive x-axis. Negative angles are measured clockwise from the positive x-axis. So vector A has a magnitude of 555 and a direction of 145 degrees. So vector A is drawn in black ink. Vector B has a magnitude of 1243 with a direction of 229 degrees. So that one's drawn in the pink. So if we kind of draw in a parallelogram, notice we've got our initial sides at the origin, terminal sides, and then what we're trying to find is the blue. We're trying to find the resultant vector. So, and then we're also trying to find the angle from standard position to the resultant vector. So the way we do this is we first of all find the components of A and the components of B, x and y components of both. So in a previous section, we found that the x component of a vector A, is A cosine theta, and the y component is A times the sine theta. So it's the magnitude times the cosine or sine of the angle. So we're going to find the x and y components of vector A and vector B. So vector A, the x component is going to equal the length of the vector, 555, times the cosine of 145 degrees. Y is going to equal 555 times the sine of 145 degrees. Then we're going to do the same thing, find the x and y components of vector B. We get 1243 times the cosine of 229, and the y component is 1243 times the sine of 229 degrees. So that's going to tell us the coordinates of A and the coordinates of B, and then we're going to add those two coordinates together to get the x coordinate of R and the y coordinate of R. All right, so if you throw those into the calculator and you round to the nearest tenth, then we end up with negative 454.63, 318.33. B, we get negative 815.48 and negative 938.1. And I'm rounding to 2 places because I want my answer rounded to 1. So you could actually round to 1 decimal place. And notice these make sense. You have a negative x and a positive y. A lands in the second quadrant where the x coordinate is negative, y coordinate positive. The x and y components are both negative, and that makes sense because the vector is in the third quadrant, so your x and y coordinates are both negative. Okay. Now we can add the vectors by components. So here's how you find the resultant. To obtain the x coordinate of the resultant, or the x component, add together the x component of A and the x component of B. So we get the negative 454.63, and we're going to add to that negative 815.48, and I end up with negative 1270.11. Step 2, find the y component of the resultant. We get that by adding together the y components of vector A and B. So we take 318.33 and add a negative 938.1, and we end up with negative 619.77. And notice our x and y components are both negative, and looking at our picture, our resultant vector is in the third quadrant, so that makes sense. All right, step 3, now it's a problem like we just did. Now I can find the magnitude of my vector by taking the square root of each of the components and add them together, squared. This is using Pythagorean theorem. So the magnitude of my resultant vector will end up being 1413.3. And then step 4, to find the reference angle, that's going to equal the inverse tangent of my y component, absolute value, which is positive 619.77, over the absolute value, 1270.11. Throw it in the calculator, and we end up with 26.01 degrees. That's not our answer yet. That is the reference angle. So up here, the reference angle, well, let me draw it again down here. Our resultant vector is down here. That has a length of 1413.3, and the angle I just found was the reference angle, the angle my vector makes with the x-axis, and that's 26.01. So if I want to find the degree measure from standard position, I need this entire angle. So my angle is going to equal 180 degrees plus my reference angle of 26 degrees, and I end up with 206 degrees. So the magnitude is 1413.3, and the direction is 206 degrees of my resultant vector.